through this quickly. If anyone wants to dive real deep into the weeds, we can do that at any time during the discussion today. But for now, we're just going to go really quick. So, in the industry, a dancer roller is a roller that can rotate and it can move up and down. And the purpose of the dancer roller is to control tension. So, we've got a dancer roller here. It can go up and down, it can rotate. Can everyone see? Should I bring it over here better, more? Or can everyone see it okay? Okay. So here's a dancer roller. We've got a web, a continuous strand of material. And then we've got springs here. And the springs are going to act as, in the industry, you'd call them transducers or load cells. They're going to monitor tension. If the spring is moving, tension is moving. And if you know about printing, if the web is moving in the printing press and it's not stable, you're printing garbage, waste. Okay. So most dancers are designed the way this one right now is set up. They're very heavy. They've got a lot of what's called linear inertia. And inertia is that resistance of a body from moving, right? If I want to scoot this pad, I have to overcome the force of it sitting here to get it to move. And again, we're going to do a little thing later, I think, if we have time, which will show that. Anyway, all I'm going to do is I'm going to pull on the web. I'm going to introduce a tension disturbance. And what you want to look at is the spring over here. Does it move, yes or no? Obviously, it's moving, right? I can do it again. Either way, I can increase the tension and it moves up and down. Or if I put a decrease in the tension, it's moving all over the place, right? I'm going to change the weights. The same mass is involved. We're just redistributing the mass. I'm not taking anything away. I'm not adding anything. So these little weights used to be close to this roller. Now they're far outside of the roller, the radius of the roller. So now this dancer roller would have what we would call more rotational inertia. What that means is it does not want to change rotational speed. If a force acts on it, it's going to move up and down before it changes speed rotationally. And again, so what? Does the web move or does the spring move? Yes. This is our printing press side. If that spring is moving as we feed material to it, the printing press is printing garbage. Okay? Is there a way to make this dancer roller work properly? And the answer is yes, otherwise we wouldn't be here. So a pure form mechanical design can be used to offset the effects of what's called rotational inertia and translational inertia, so that this dancer roller wants to change rotational speed and wants to change position up and down in equal amounts so that the resulting output is a stable web. No electronics, no motors, nothing. It's filtering the disturbance. It doesn't sense a disturbance and then correct. It's correcting in real time because it's filtering in real time. If you don't have a system like this, then you're going to use load cells connected to a drive, and you have to have a very precisely tuned system, very high frequency response, where those load cells are attached to an idler roller. It's I saw a little tension increase. I gotta speed up to feed more web so I can take care of that. Or I gotta hold back, and you have to have this very dynamic connection, very high frequency response, and it's all based on electronics. The reason I say a microcosm is we are always driving towards pure form designs. Designs that are mechanical in nature. We certainly will go to electronics when we need to. I mean, this machine here